Hello, welcome to your Project 1 video. So hopefully you've already installed GeoGebra and got it up and running here. And you'll be given a window like this. Now GeoGebra is a very powerful tool. It replaces basically a graphing calculator. It does everything a graphing calculator can do. We're going to do it just a few features of it here. But if you look at it, you're given basically an X and Y axis. And down here in the input bar, what we can do is we can type anything we want. And GeoGebra will graph it for us. Y equals X squared. We can type crazy things like y cubed minus y equals x to the second. We'll get that, whatever that is. We can put in some functions. F of x equals sine of x, plus 5. Way up there, crazy stuff. Whatever you want to graph, you can move it all around. But what we're going to do is we're going to start by opening hopefully a file that you downloaded. Click don't save. That's just garbage anyways. And hopefully you downloaded the Project 1 model maker file from Blackboard somewhere into your computer. And we can open this now. And what this is going to do is it's going to open a bunch of different windows. So this is our main window here. I got to move it around for a second, because we also want to move the algebra window over here, but we'll be able to use it later. And also a spreadsheet window. And we'll move the project window up there so we can take a good look at it. So here we've got our basic graph. And what we're going to use this is we're going to use this to help make a model for our file. And so the first thing we want to do is we want to insert our drop pattern into this program. So if we go up here to Edit and click on Insert Image from File, again, we'll just get a nice dialog box. Hopefully you downloaded your drop pattern from Blackboard. These are all on Blackboard as well again. And what you do is just click on it, hit Open, and it's going to dump the file right there, and it's kind of hard to see. So what we got to do is we got to move this thing around, and we right click, and go to Object Properties. And that is not what I wanted to open. So we right click again and click on Object Properties. And this time what we want to do is we're going to go over to the position. And what we're going to do is in corner 1, we're going to make the first corner, just going to have to type in LL for lower left. Corner 2, we'll type in LR for lower right. And corner 4, we're typing UL for upper left. I set these up ahead of time to hopefully work out. And so what it did was it put in our file here. It looks pretty nice. And what we can see is that if we zoom in a little bit here, so if we click on this little drag arrow and then click on zoom in, what we can do is we can zoom in and we can see that this 80 seconds, this one was from the file and this one's from GeoGebra, and they pretty much overlap. And a basic key here is going to be to make sure that your grid basically looks like it overlaps. Now it might be close. So if you click on the little pointer arrow over here, what we can do is we can click on these dots to sort of move it around. So like if our grid doesn't look pretty good, if it looks a little messed up, we kind of just move it around a little bit until it starts to look pretty good. It overlaps a little bit, and you're just going to have to use your best judgment here. It's not going to be perfect. Modeling's hard. It's okay. But what we'll do is we'll do our best. We'll get it to line up kind of there. We can see that our vertical grid lines look pretty close. Our horizontal grid lines look pretty close, and it's going to be good enough, okay? It lines up close enough, everything's good enough. I mean, we're not going to be worried about being off a second here. So once we've got our file in there, the next thing we want to do, also we can move around any of the points we want. We could click on this point and drag it all around to move this around. We could also click on this point up here, drag it all around to move it around. But the next thing we want to do is we want to put our points in here. So in the spreadsheet window, what we're going to have is in column A here, I'm going to have times. These are my times 0, time 10 seconds, 20 seconds, 30 seconds, all the way down. We scroll down, they go all the way down to 240. Over here, what I did ahead of time was already typed in the numbers. So at time 0, we're at height 0. At time 10, I looked at my graph and estimated we were at 82.7 feet. At time 20, I estimated that we're at about 142 feet by looking at my graph. Time 30, I estimated and said we're going to be about time 200. Hopefully you did these earlier for the velocity graphs. And so what you want to do is you just want to type them all in down here. And once you've got all your heights in at different times, what you want to do is you want to highlight them all. And then up here, click on the little triangle. And what we want to do is we want to use these to create a list of points. And once we click Create a List of Points, and we click Go ahead and create it, we decided we're going to name it List 1 here. What it's going to do is it's going to plot all of our points along there on our graph that we collected earlier. So this is the start of making a model for our graph. What it also did is it listed them over here in the algebra window. In the algebra window, what we've got here is we've got we've got this thing called list1, which has a list of all of our points, and then we've got all the coordinates of all our points over here as well. Now that we've got this going, what we can do is we can try to make a model. That is, we can try to figure out if there's an equation that's going to closely match all of these dots. And to do this, what we want to do is we want to type in the following. We want to type fit poly, and then what's going to pop up is this nice little window, and we're going to hit tab, or enter, and then what it's going to do is it's going to tell us, well, first we need a list of points, and we called our list of points list1, and then if we tab over, we need to decide what degree of our polynomial we want, and what we're going to do is we're just going to use the letter n for now. So what you can also do is just type this in exactly. If it screws up, just delete it and type this in exactly with square brackets and hit enter. And what's going to do is it's going to try and make this curve that tries to go through as many points as possible. And currently what I've got down here is I've got n equals 3. So this is telling me this is a degree 3 polynomial. And actually if I click on my algebra window, this is the polynomial it tried to come up with here. So what it's got here is it's got this degree 3 polynomial that it's trying to fit through the curves as best as possible, through those points. And what I can do is if I click on this window in my main project window, and I move this slider back and forth, what it'll do is it'll try to increase the degree of my polynomial to try to fit the curve better. So here I've got a degree 9 polynomial now instead. It seems to be fitting a little bit better. It's changed my polynomial over here, actually. So what you can see is you've got 0, 0, or very small numbers, very small numbers, very small numbers. And if I scroll on over it, it just makes a bigger, more crazy polynomial. But what it's going to do is it's going to start fitting my curve better. And as I keep increasing my n, it looks like it's getting a little closer to the actual fit of my curve. But then some places are getting a little messed up. I mean, this is pretty crazy. It doesn't match our curve at all. And so what we want to do is we want to kind of go back and forth a lot until we get one that we think looks pretty good. So I'm going to stop there at, say, I think 15 is pretty good. Because if we do 16, it looks a little loopy. So let's go back to 15. And what I'm even going to do is I'm going to go back and click on my function. And I'm going to go to Object Properties after I right-click on it. And I'm going to go to Color. And I'm going to change it to the color red. Let's do a dark red so it stands out. So what we can see is now this seems to be dark red. So what we can see is the red graph is our polynomial that we've got an equation for. And the black line was our original coaster. We can see some places it matches pretty well. You know, from point U on down, that's pretty close. It's matching these points. It actually hits these pretty exactly and goes through them. You can see it sort of misses out here, so there's this bit of a discrepancy. It doesn't capture any of these big drops, but it's a good graph in its own right. It would be a drop pattern, and so this would be our model. So this is the graphical image of our model, and we've also got the equation of our model right here that we can just copy down. And I think if you actually right-click, you might be able to copy and paste that, or you might just have to copy the numbers down. I'm not really sure exactly. Another thing that you're going to want to do, though, is what you're going to want to do is you're going to shrink this window up a little bit here, just by dragging the corner and dragging it in. And then what we can do is we can export this as a picture here. So if we go up to File and Export, Graphics View as Picture, just don't click anything there, it's all fine, and hit Save. And what this is going to do is it's going to let you save this image here as a picture. So we'll just save it as my model. Enter, and now we've got this image saved so that we can insert it into our report and print it off. And so the last thing you'll want to do is, of course, is go back, click on your function here that you made, and if you hit either Command-C or Control-C, your standard copying in your computer, what you'll actually be able to do is you'll be able to copy and paste that right into your report. So you don't have to type everything again, you can just paste it on in, and hopefully you don't have to record too many numbers there. What you might want to do also at this point is, of course, go up to File and Save, because you don't want to have to do this again. But if you have any questions about this or need a little more help getting yours to work, please let me know. Big things to notice again, it's going to be a bit of your gut instinct to decide what level of n to use here, which one's close enough. That's a bit of a judgment call. That's why it's modeling, it's not an exact science. Also, when you insert your image, like I said, you may have to play around with some of moving these points around to get everything to line up. Your goal is to be close, you know, as long as you're reasonably close. I'm not going to sweat it too much. It's an imperfect world. But if you have any questions, let me know. Otherwise, have a good day. Bye.